Hello, Dr. Uttan Kumar.
Hello, sir. Good morning.
Good morning. Yeah, thanks for joining. So we'll start the session. If you want to test your
Yeah, sure. Yes.
screen, you can do it. Okay. Good morning, all. Welcome to the second day of the workshop. With us here, Dr. Uttan Kumar. He is an assistant professor and Infosys Foundation Career Development Chair Professor at IIIT Bangalore. He did his master's in Netherlands in the University of Twente in the area of geoinformation science. And also he did his PhD from IISc Bangalore in the area of algorithms for geospatial data analysis. Then later he worked in NASA, Arms Research Center, California for 4 years. He has many papers, like 30 research papers and 16 book chapters and 69 papers in conference proceedings. Also, he delivered 95 invited guest lectures, and he is also a reviewer of 29 scientific journals. Apart from that, he received several awards, such as like Indian National Geospatial Award 2021, IEI Young Engineers Award 2015, NASA Group Achievement Award by NASA, and Certified Sentinel of Science Award 2015, and Earth and Planetary Science. Further, he received Best Paper Awards and Young Scientist Award also in 2011. So he is going to talk about the machine learning for geospatial analysis using multi-resolution remote sensing data. So the floor is for you, sir. Thank you.
Good morning, everyone. Welcome to the two-day international online workshop on geospatial data science and GeoAI. So thank you very much for the introduction. And I am honored and privileged to be here presenting my work. So let's begin now. Just switch off my video and switch it on again at the end of the talk. Right. So basically in this talk, the idea is to talk about some of the machine learning algorithms and also advances in machine learning for data processing using multi-resolution remote sensing data. And mostly these data sets are acquired to be used in different applications in earth sciences. So as already introduced, my research areas are spatial data mining, also the popularly known as data science, or in some aspects they call it data analytics. And I also work in applied machine learning, remote sensing, GIS, and spatial computing. And since most of the data comes in the form of images, so of course, a lot of digital image processing techniques are also used. Along with these, I also teach database systems at the institute and also focus on spatial databases for the master's and PhD programs. Okay, so I would start the presentation by giving you some quotes. And in fact, most of us are thrilled when we talk about data science and when we talk about machine learning, etc. But it is actually the fact that the field of statistics is one unique field that is constantly challenged by numerous scientific problems and the real world problems in the industry, and it is not the computer science. So people who are doing core research in computer science would be already familiar that most of the algorithms and we talk about in machine learning in computer science are essentially statistics, and they have a foundation in mathematics, right? Probability, statistics, and calculus, and so on. So it is actually the field of statistics that is more in demand to solve the real world problems. Okay, now the thing is, currently we all of us know that there is an increasing data volume, and we have limitations to analyze that increasing data volume, and therefore we try to take advantage of the low cost of machines currently available, and these machines help us to actually analyze these huge data sets. We all know that the size of the data have exploded in various dimensions and brings several inherent challenges, including data storage, organization, searching through the data to look for a interesting pattern. All these ideas joined together have led to a new field called spatial data science, and that is all we are talking about in this current workshop, through different forms of applications, through different talks from eminent speakers, and so on. So what's the challenge in this data processing or data analysis? The challenge is that how do we make sense of this data? How do we extract some of the important patterns? How do we come out with some of the trends and uh, and understand the data? So this is what we call learning from data. Okay. We already know that there are numerous sources of data, and be the remote sensing or telescope scanning the skies, or we also often do scientific simulations which we generally generate lot of data. So most of the traditional statistical techniques that we have been using for a long time do not actually work on such large data sets. So in this context, the field of spatial data science and machine learning are really helpful because they classify the data, they segment the data, they help us in hypothesis formulation, and they help us to extract patterns from the data on which further we can plan to apply some of the statistical tests or hypothesis testing. Right. So we all know machine learning are actually computer programs. Okay. And these programs tend to improve through incremental learning. So they automatically improve with experience. Okay. So the idea is that let's look at machine learning problem from different perspectives to understand the setting algorithms, underlying assumptions behind each of these algorithms, and so on. So I'm now going to a little bit deviate from the current topic and talk about one of the most cited machine learning researchers in the world, and he happens to be Professor Shirani from Stanford University, and he is a professor in the Department of Biomedical Data Science and Statistics. Okay, so he has also written books, and those are available on the web. Okay, so I happened to read his website, his official website at the university page, and I copied paragraphs. Okay, and I would read this for you. So he says, in elementary and high school, I loved mathematics. As an undergraduate in university, I took mostly math and computer science courses. I found that math got to be too abstract for my liking, and computer science seemed concerned with little details, trying to save a microsecond or a kilobyte in a computation. In statistics, I found a subject that combined the beauty of both math and computer science, using them to solve real-world problems. Next paragraph. Today, statistics is more important than ever because of the ease with which we can collect large amounts of data. The challenge is to sort through all of this data and separate out the consistent pattern from the noise. This challenge now touches many areas of science, engineering, medicine, finance, and even the arts. Statistics is a young subject, still finding its way. It is an exciting time to be a statistician because of the enormous computational tools at our disposal. How best to use these tools is a fundamental challenge for our subject and the focus of my research. There is something interesting in the two paragraphs. Okay, many of you might have already noticed it, and some of you might have missed it. Okay, so I will just highlight that interesting part. The interesting part is that there is no mention of the term machine learning in it. Okay, so as a statistician, as a person coming from the Department of Biomedical Statistics, he is currently one of the most cited machine learning researcher in the world. The message is that machine learning is not a subject restricted to only computer science people, but people from other backgrounds have been using it, have been developing it for numerous applications in different domains. Okay. So how did statistics or statistical learning, more better term is statistical learning, evolve? At the beginning of 19th century, Legendre and Gauss published their paper on method of least squares. Okay. In 1936, then Fisher proposed a linear discriminant analysis. We all know about this. 1940 came the one of the great techniques, logistic regression, which is still a very popular technique used in data science now. 1970, Nelder and Wedderburn coined the generalized linear models. 1980s came the nonlinear methods. Then somewhere around mid-80s came the classification and regression, also known as CART, by Bremen et al. 1986, Hasty and Tipshirani, whom I was just talking about, they coined the generalized additive models. Then onwards came statistical learning. Today it is more popular as machine learning. So we all know different forms of learning and consider these examples shown in the slide. Computer learning from a medical records, trying to find out the best treatment for a new disease, or a smart home trying to optimize energy cost, maybe electricity or water usage, or even a personal assistant such as a Google Assistant, Alexa, Cortana, and Siri, and so on. So all of them learn from our day-to-day behavior, and they give suggestions. They help us to plan our day better. Maybe if we are planning to go to office, university, institute, they update us about the weather outside or about the traffic situation, so on. So in all of these examples, our concern is not to analyze the meaning of the English word learning. Okay. So what we are talking about here is instead to define precisely a class of problems. Okay. Class of problems, these problems encompass interesting forms of learning. In the process, we try to explore different algorithms to solve some of these problems listed here. We try to understand the structure of the problem. We try to see what are the processes that are involved in the problem, and so on. Okay. So most of us sitting here are already aware of the terms classification and prediction. We all know in classification, we have a category class label, which can be a discrete or a nominal, such as ID numbers. And here we actually build a model, construct a model based on the training data. Okay. And then when new data arrives, we try to classify those new data sets. On the other hand, prediction, which is also quite popular in statistics and computer science, we try to model continuous valued functions, and mostly they are used to predict known or missing values. Right. In learning, when we talk about classification, mostly these are topics which we are already aware of. Supervised learning, where we have a support of training data to build a classifier, and unsupervised learning, where we do not have a training data and we use some kind of a natural grouping of objects based on certain attributes. Okay, and these groupings are used to form clusters of data. So then it depends on the user, the data analyst, to infer the meaning of these individual clusters. Right. So all of us have seen examples of autonomous cars, and they typically use some form of supervised learning, mostly deep learning techniques. So the driver trains these cars on a daily basis, maybe trying to drive the car for a certain number of hours in different road conditions. And then currently it is claimed by many of the companies that these cars have performed even better in many circumstances than human drivers. So these are a form of supervised learning. Here is another example of 1.1 billion users of Facebook. Okay, so what you see on the slide are white patches. against a blue background. Okay, so these white patches actually are showing the density of Facebook account holders across the globe. Okay, and popular technique called DB scan has been used to generate this particular map of the number of Facebook account holders across the globe. Obviously, there are large number of users in North America, Europe, UK, India, and Southeast Asia. Whereas you can see there are no users in China because of the fact that China doesn't allow Facebook to operate in the region. Okay, so what is cluster? So clusters are a collection of data objects. They are these sections are similar to one another within the same group and dissimilar to the objects in other groups. There are numerous applications of clusters and cluster analysis, and they are often used as a standalone tool for different applications, also as a pre-processing step for many of the algorithms. Consider the example shown here. So this is a snapshot of the news today. Okay, and we see a different news from different areas. People are interested in sports, people are interested in entertainment, people are interested in politics, and so on. So what would a clustering algorithm do? A clustering algorithm basically will try to cluster them based on certain keywords. Okay, for example, entertainment, politics, sports, so on. So summarize, uh, uh, we just talked about models that can be used for different machine learning applications. Uh, in the supervised learning case, we have training features and training labels that are fed to learning algorithm. To that, we use algorithm to develop a model, and developed model is then used to predict class labels. Finally, we have a predict label and a test label, which are fed to a evaluation algorithm, which gives us some kind of a accuracy of the model. Right. So there are certain issues in learning, and these are also very much valid in spatial data science. Okay. For example, if you have typically gone through a formal machine learning course, or if you have studied it on your own, okay, you may have learned a large number of techniques, algorithms. Okay. So one very obvious question comes to our mind: which algorithm performs best for what kind of problem? For what settings? Okay, and the answer to this question is not direct, not easy. One may have to actually do several experiments under different settings for different types of problem to find out the best performing algorithm. Okay. In spatial data science, often people talk about space, right? So sometimes collecting training data from a remote location is not easy. Maybe think about a mountainous area, or an area which is not easily accessible. So in that case, how much training data is sufficient? Okay. Then if you have some prior knowledge about a space, about a particular place, can we use that knowledge to to improve the process of target concept? And other point to ponder is that let's say you build a model today, and is your model also equally valid after 5 years? Will your model automatically alter its representation, or we need to build a new model from scratch, or we need to just retrain the existing model with the new attributes or new data? Right. So how long can you use your build model in context of time? Right. Now let us slowly come back to spatial data science and talk about these two worlds. So what you see on the screen are two worlds. We all know about the natural world. Natural world is often self-regulating. The various features or various observations on in the natural world, they regulate on their own. On the other hand, we already know humans have greatly altered some of the land cover or land use features. maybe converting some of the agricultural land, farmland to buildings and constructing bridges and so on. That is more of a constructed world, and it is more like a managed world. So very more often than not, there is an increasing conflict between a self-regulating world and a managed world, right? So uh, when we talk about the world, when we talk about space to study, we need to look at the data in different context. Okay, we can look at the data by, for example, trying to see the whole world at a time. And what do we get when we try to analyze global data? We try to get patterns. We try to get linkages. We try to get trends. Patterns, for example, patterns of rainfall, trends of rainfall, or patterns of heat waves across the world, or patterns of cold across the world. When we talk about smaller places, okay, when we talk about smaller places, we see the place as a community, as a neighborhood, or as a district, maybe at a political level. So it is also true that phenomena that happen at smaller places or in a community or in a neighborhood might ultimately contribute to some kind of a pattern or trend at a global level. Right. So we all know that in this context, GIS or geographic information systems are really very useful to study different phenomena, objects, etc. on the earth. And they give us very useful information right away from very obvious information. So what are the obvious information? Where things are, what things are. Okay, where and what are two very interesting words that are often answered through a GIS application. GIS stores all of these uh, information or data in the form of thematic layers. As you can see, we have a layer on customer, building, streets, and so on. Okay. Now, uh, GIS can actually help us in many ways. It will answer what question, where question. So what can be a locational question? Where can be a conditional question? Okay. Trendy question. So trendy question is, for example, how has it changed over a period of time? Okay. Relational question. What data are related? Model-based question, which are often answered through scenarios. So we develop a model and simulate the model and generate a scenario. And it will help us to answer questions. For example, what if? Now I'm going to show you a very small example of an experiment which answers what, where, and how. Okay, so we all know about the real world, okay, and the managed world. Real world, of course, is very soothing and very beautiful. Real world has lot of natural resources, okay, in the form of forest, land, water, etc. But we need proper planning to ensure that there is a sustainable use in the use of these resources by humans, or else we may end over exploiting these resources. Okay, so in this context, there are two terms which are very common, and you will find these two terms frequently occurring in numerous literatures. One, first term is land cover, which refers to the physical and biological cover present over the surface of land. Okay, for example, it can be water, vegetation, soil, etc. There is another term, land use. And land use is actually defined from how humans are utilizing the land. For example, we can utilize the land for agriculture or for building construction, which can be either residential or commercial, and so on. Now, more often than not, there has been huge changes in land use and land cover across the world. Why there is a change? Because of humans. Humans have modified Earth's terrestrial surfaces for different purposes. Right? This is a very common phenomena in most of the growing cities. We see large amounts of farmlands converted to buildings, lakes being encroached and converted to high-rise apartments, and so on. And have detrimental effects. We all know, we all encounter this every year: global warming, flash flood, and then alteration in the rainfall pattern, precipitation, groundwater depletion, which is very common in most of the large cities, and so on. So I'm going to show you a very small case study about the city of Bangalore. We all know that the city has actually grown a lot because of many people coming in for jobs, employment, education, and so on. And therefore, the city boundary has actually increased in all directions. Right away from the north, the new airport has come, which is slightly away from the city, and then on the eastern side, western side, several new colonies have set up. In the southern side, for example, where I am currently residing, this electronic city, which is a new development, a new cluster away from the city. Okay, so in fact, there is a bridge that connects the city, the part of the city, to this electronic city area. Okay, so the message here is that the earlier boundary, political boundary, which was known as BBMP, Brihat Bangalore Mahanagar Palike, or Greater Bangalore, this boundary is older now because city has grown more in all directions, surpassing the boundary. A bigger area was considered for this experiment. And as you can see, this is an image, Landsat satellite image of 1973, classified into 4 classes. We have red pixels showing the urban areas, and green pixels showing vegetation, blue pixels showing the lakes, and the pink pixels showing other classes. So it was actually true that the city was called the city of gardens and city of lakes because of the greenery and because of the numerous lakes that are part of the city. Okay, now you can see how the city has actually been growing in different directions across the year. In 92, in 2000, in 2004. So in 2004, you can see some of the roads like your Outer Ring Road and Old Madras Road and Hosu Road. They have come up. 2009, 2014, 2018. So obviously, we have some more data about 2022. Not much change because of the last 2 years, but obviously now roads, highways are clearly visible, and we can see urban areas have expanded in all directions. Okay, so one of the challenges in spatial data science is that how do we visualize these kind of changes? Okay, probably one way would be to represent the changes happening in each year in different colors. Okay, but yes, one can again come up with very intuitive ways to depict these changes across the year. What did this analysis give us or reveal? Okay, it revealed some very interesting patterns about location, condition, and trends. Okay, built-up area, for example, has increased by 1794% in the last 45 years. Okay, and there is a huge decrease in vegetation, almost 66.5%. Okay, and huge decrease in the number of water bodies. So now it has reduced by 3.22%. Already the percentage of water spatial distribution was low, and 3.22% decrement is actually a big number in terms of hectares. Okay, so very nice information was revealed in the form of trends. What is the current trend that is existing across the city? Okay, now I will shift the gears and move to a slightly more insight into the world of classification. So the example that we saw in the last few slides trying to visualize the spatial distribution of urban areas in the city. Okay, so as you can see, we use some of the machine learning algorithm, essentially the random forest algorithm, classify every pixel, okay, and assign that pixel to one of the 4 classes that we saw, right? So we also know that the classes here are mutually exclusive. So every pixel can belong to one of the 4 classes. Right. Now, the thing is that the point to note here is that on the Earth, most of these classes that we just saw and we talk about are not strictly distinct. Okay, and it results in a new type of pixel called mixed pixel. As you can see in the figure here on the top, so this pixel, for example, is a poor pixel because it shows only water. This pixel, for example, shows a mixture of lawn and water. Okay, a green park and lot and water. This pixel, for example, shows a mixture of parking lot and some green lawn. Okay, so actually every pixel is a mixture of more than one class because the physical features on the Earth do not have a distinct boundary to match with the real world phenomena. Okay, so as you can see in the figure here, in the mixed pixel, typically you may have water shown in blue pixels here, vegetation shown as V here, and settlement shown as S here. Okay, I'm talking about a single pixel, and a single pixel is actually the basic element of an image. It cannot be broken further, right? So traditional machine learning algorithm, for example, SVM, random forest, etc., they will assign one single class to the pixel through a per pixel classification. More often, this particular class will be the one which is dominant in that pixel. So as you can see, vegetation is dominant. So vegetation has been assigned to this particular pixel. Okay, but actually the fact is that this particular pixel has 20% settlement, which could be built up, 60% vegetation, and 20% water. Okay, so we have been forcefully assigning one class, but actually the cell is a mixture of more than one class. Okay. Now let's see one more example here. So on the top, we see two cases in figure A and B. Figure A shows that the sunlight hits the earth, okay, and goes back to the atmosphere, which is then sensed by the satellite. Figure B shows that sunlight hits the earth, then it is multiple scattered because it hits the earth. Sorry about it. It hits a tall building, might hit a aeroplane or a bird, and then it might go to the atmosphere. Okay, this is a case of non-linear mixing. Okay, so I will talk about this later. Now, as you can see in the figure below, so we are talking about what is mixed pixel. As you can see, object 1, object 2, object 3, the background. 3 objects mixing in one single pixel. And here, 3 boundaries, 1, 2, and 3 are mixing in a single pixel. Or let's see the example here, where we have a straight line passing through the pixel. So this could be a road, for example. So all these are examples of mixed pixel. Okay, so for a long time, there was a paper published in 1992, and that method was the only method available for almost 10 years to solve this kind of a problem. Okay, so what is the objective here? Objective here is, instead of assigning one class to a pixel, can we try to decompose and find out the proportion of different classes in a single pixel? Okay, so let's consider this example here. We have 3 classes, 1, 2, and 3 mixed in a single pixel. So the paper published in IEEE Transactions on Geoscience and Remote Sensing said that we can actually model the proportion of various classes in this pixel. Okay, how? So here y is the digital number of this particular pixel, location x comma y, which is equal to the summation of the product of reflectance of class 1 into area of class 1, reflectance of class 2 into area of class 2, and reflectance of class 3 into area of class 3, plus some random noise eta. Okay, on this we impose two constraints. One is called the non-negativity constraint, which says that none of the classes can be negative, and the other is sum to one constraint, which says that if you add up all the proportions of the different classes in a pixel, it should be equal to 100%. Okay, so the earlier paper which I'm talking about had used ordinary least square to solve the problem. Okay, and here as we can see, alpha happens to be the proportion of class in a given pixel. Later on in around 2000 and 2002, Professor Chang from University of Maryland, who works in the Department of Electrical Engineering, came up with a new idea saying that let's treat image as a signal. Okay, and let's assume that let's assume one class at a time. So for example, if we are considering class 1, assume that class 2 and class 3 present in that pixel are noise. Okay, so later on consider class 2 as signal and consider class 1 and 3 as noise. So every instance, consider one class as a signal, the other class as noise. Okay, now replicate this idea to earth sciences and think about land cover. So let's consider I'm interested in urban areas or buildings. Consider building to be a signal and all other classes like your vegetation, water, etc. be noise. Okay. And then he came up with a nice algorithm called orthogonal subspace projection. So here he proposed a model called DU model. D stands for the desired signal, U stands for the undesired signal, and he talked about maximizing the signal to noise ratio and skipping some of the details. He then finally came up with an equation alpha p here at the bottom, which gives us the proportion of the pH target material at a particular instance of time. Likewise, we can do it for every class, and we will be able to decompose the signal from separately from noise, and we can estimate the proportion of every class in the pixel. I will come back to this discussion later on, but show you some of the results. So, applying the least square solution that I just talked about in the older paper published in 1992, we came up with an unconstrained least square solution given by alpha here, which is E transpose E inverse E transpose Y, and E is the reflectance of that particular class, Y is the reflectance of that particular pixel, and alpha is the proportion of that particular class. Okay, so I will come back to this point later on. So the same set of techniques that we just talked about was assuming that things are linear in nature, but very often it happens that things are also non-linear in nature. Okay, so in this particular paper, we had talked about a non-linear mixture model framework that could actually consider multiple scattering of reflected light in the atmosphere. Here we use the training times, one using orthogonal subspace projection, and then again we use a multi-layer perception architecture to solve the non-linearity in the particular mixed pixel. So just keep details. Here is the MLP model which used the logistic function and the structural diagram of the MLP. So to test the algorithm, we had first taken simulated data, computer simulated data set, and we were able to download spectral signatures of 4 minerals, namely alunite, bodigonite, kalonite, and calcite. And these spectral signatures are available on the website of Jet Propulsion Laboratory. From this signal, we had used this particular equation to simulate 200 synthetic bands. Okay, and instances of band 1, band 100, and band 200 are shown in the first row. In the bottom figure, we have a hard classified map generated from a machine learning algorithm. So on the top, we have an output considering the linear mixture model case, and at the bottom, we have output from non-linear mixture model, that is through the neural network. Now we see that here we had 4 minerals, and corresponding to each mineral, we have one output, namely BCDE, linear mixture model case, and ABCD at the bottom for non-linear mixture model case. So we see that each output ranges from 0 to 1, and the proportion of a class shown in decimals, which can be represented in percentage. If we add A, B, C, D, or in the bottom figure, all 4 outputs, the sum should be equal to 1. So how do we interpret values towards 0 indicate, so we have one output for every class. Okay, one output for every class instead of one output for all the class, which we had seen earlier. Okay, so we had 4 classes here. Therefore, for 4 classes, we have 4 outputs. Output values ranges from 0 to 1, where 0 represents absence of a class. Okay, 1 represents full presence of a class. Intermediate values, for example, 0.5 may represent 50% presence of that class. Okay, this is how we interpret the output maps, which are also known as abundance maps. And in the bottom figure, we see trying to plot the real proportion versus the estimated proportion from the model and see how good are the plots. Then the algorithms were applied on real world data, and these are small snippets of images shown for center part of the Bangalore. So this is also lake here. This is a race course, and this is a railway station shown in 4 different resolutions: 1 meter, 4 meter, 25 meter, and 250 meter. So the idea is to take the robustness of this algorithm across different resolution of data. We see the output from both the algorithms for 2 class, vegetation, non-vegetation, and 3 class, urban, vegetation, and water. As you can see now, the Alsur lake and another lake are now quite prominent. Okay, so they are white in color. White indicates full presence, and black areas represent absence. So all the black areas are the non-water area. So they can be either urban or vegetation. Okay, this is another implementation on the Indian remote sensing data, IRS-1D, and this area is belongs to northern part of Bangalore city. There is the new international airport. This is Nandi Hill, which is a popular tourist destination. People often visit this, and Nandi Hill has quite an amount of forest and plantation. This particular settlement is called Balapur. So this is straight away from the airport. If you don't take a deviation, we reach Chikbalapur town. So this particular scene has 6 classes: agriculture, built up in the form of township, that is Chikbalapur town. Forest and plantation are mostly mixed and are present on the Nandi Hill area. And there is a huge amount of wasteland and very scanty water bodies, very less water bodies. So we see that agriculture is dominant in the form of yellow color. Okay, and even pink is dominant in the form of wasteland. So as we all know, Kolar, this belongs to the Kolar district, and Kolar district is a dry district, so there are huge amounts of wasteland in that area. Now we have 6 different outputs for each of this class shown in figure B, C, D, E, F, G. Okay, where B represents the presence of agriculture areas, C represents the presence of settlement, which is Chikbalapur town. D and E represents forest and plantation. Mostly forests are on the Nandi Hill side, and F represents the distribution of wasteland, and G represents the distribution of very small water bodies here and there. Okay, so you can see in this graph, the errors are being analyzed, and errors have mostly happened in analyzing agriculture and wasteland, because in northern part of that district, there is a huge amount of agriculture land which were fallow, and the signature of fallow land mixed with wasteland, getting confusion for the classifier to discriminate or to distinguish them. Okay, these are some validation tables using correlation, RMSE, see which approach is actually better. And the message we got is that non-linear mixture model is obviously better in terms of giving more heuristic output, but is harder to implement. So most of the current state of the art only talks about linear mixture model cases, although there are some papers published even on non-linear mixture model. Okay. Now I will talk about a small work, just a continuation of this. Most of the applications that we saw till now, we had, for example, considered the buildings. Okay, so we considered all types of buildings in a broader class called settlement. Okay, but we know that buildings are made up of different materials. For example, cement can be used in the form of concrete buildings, or we can have a asbestos roof or tile roof, and so on, right? So we see that within the buildings we have a variation. Okay, similar analogy holds on for water. Water can be clear water, turbid water, contaminated water. We have broadly classified them as water. Now the question is, can we think of technique or way incorporate this variability, this variation within the classes? Okay, to solve that problem, we come up with a method called variable end member constraint least square. So here we extend the idea of constraint least square, which was actually talked about in the previous OLS technique introduced in the year 1992. And end member is actually a class. So end member means class. So can we simulate this variability in the class in a particular mixture model? Here is a flow chart. I'm going to skip this particular implementation. More details are given in the paper, which anyone can refer at a later point in time. And the idea is to see whether this improved method can perform better in case of small variability, medium variability, and large variability within the different classes. Okay. For example, even within the vegetation, we have numerous species of plants that can be broadly classified as vegetation. So can we think of accommodating the variation within the green plants? Those variations can be small, or can be medium, or can be large. How well can we separate them? Okay, now let's move on and talk about big data. We have been talking about smaller toy data sets, smaller at a city level, simulated data, etc. But how will these algorithms perform when we actually think about data? We all know there are numerous space-bound satellites currently providing huge amounts of data from the order of petabytes, exabytes, zettabytes, yottabytes, and some of these are new terms. So, for example, the climate change data might be the order of 350 petabytes by 2030. Right. So there are currently large number of data projects going on around the world. Let's talk about the Landsat Wealth program, or the climate projections, or talk about the tropical rainforest measuring mission TRMM, global drought program, global forest monitoring, climate downscaling, and so on. Multiple projects are going on in different domains. Now I will come back to the topic of unmixing a mixed pixel, which I had left some time back. And recently, we wanted to deploy this particular technique on a bigger data sets, moving away from smaller data sets. So the issues of scalability, computational and time complexity, accuracy, and how robust would be the algorithm noise was very important. So later on in the year 2012 and 13, we came across a new set of techniques, this particular domain, and this particular set of techniques is broadly known as sparse unmixing, which uses sparse regression. Other techniques can be grouped, let's say, in signal subspace, such as the orthogonal subspace projection. There is a group of researchers from China who also propose geometrical techniques to solve this problem. And of course, statistical techniques are one of the oldest techniques that people have used. So, a group of researchers from uh, Europe. So they, especially to mention Professor Marcus Diaz, who passed away in the corona last year, had a series of papers talking about sparse regression and sparse unmixing. So this is a group from Portugal, and they had tried to come up with a new set of method to solve this problem. But we saw that most of these papers, they only work on very small synthetic data of, let's say, 500 rows by 500 columns, which is quite easy to work on and show that these techniques actually surpass the performance of other techniques. But what happens if you deploy them on larger data sets? Will they perform equally good? So uh, we found that the sparse regression techniques are quite slow in implementation. We moved back and then talked about the statistical methods, which are still very robust. So the problem was that this particular statistical implementation was done in a form which was an unconstrained solution. So we contacted Professor Chang from University of Maryland, and he gave us the MATLAB code, and we converted the MATLAB to C++ program and found that it is quite slow and takes 2 hours to process one image of 5,000 rows by 5,000 columns. So we modified that particular algorithm by including non-negative least square. This technique was borrowed from a book written by Lawson and Hansen. The book title is Solving Least Square Problem. And then this NLS extended the idea of fully constant least square, that is imposing both the constants together. So upon improving this particular algorithm, we saw that the speed of the algorithm greatly increased to almost 2 minutes, requiring 2 minutes to process every scene of 5,000 rows by 5,000 columns. Now, when we talk about bigger data sets, big data, okay, especially in the spatial data science arena, collecting training data is also quite a challenge. Therefore, it is not at all possible to go around different countries and collect training data. So fortunately, there was a work from Professor Small, who is working at University of Columbia. And he published a paper in that year in the journal Remote Sensing of Environment, where he collected training data for 3 different classes: substrate, vegetation, and dark objects, where substrate represents soil, sediment, rock, etc. Vegetation represents green photosynthetic plants. And dark objects represents clear water, deep shadows, oceans that include Pacific Ocean, Atlantic Ocean, Indian Ocean, and so on. So we thought of utilizing this particular end member library for this particular problem, solve the global data classification. This is a snapshot of the global data. It has 8,003 scenes. Every scene has 5,295 rows and 5,295 columns, altogether consisting of 224 billion pixels in 6 spectral dimensions. This is the flow chart showing the process to which the global data was planned to be analyzed, and essentially after unmixing is done, we had used a random forest classifier, and then we had different benchmark data sets to validate the current output. So altogether there were 350,000 scenes to be analyzed in the database, and 350,000 scenes, which is a huge amount of data. You can see the sample out here for the entire globe. So on the top, this is abundance map for substrate. This is for dark objects, and this is for vegetation. So as you can see, that part of Sahara Desert, Thar Desert, etc., are shown here in the form of dark orange color, which is substrate. And then if you look at figure here, it represents the distribution of global vegetation cover. And this particular figure is called NDVI, Normalized Difference Vegetation Index, generated from the same data. The idea was to see whether the vegetation abundance map does it look similar to the global vegetation distribution through NDVI. Now you can see that most of the vegetation area here, etc., are also being shown or revealed through the unmixing map. So this particular work was published in the Remote Sensing Journal. Validation was quite challenging, so we only focused on some part of the study area, and then for this particular area, we did the validation for all the 4 classes. Other related work was trying to use CNN architecture to identify every individual tree to a high resolution 1 meter data. And for this, again, we had almost close to 450,000 scenes to be analyzed. So as you can see, individual trees being classified using CNN, and the distribution of tree cover across different states obtained from that particular output. So the proposed output was actually 6% better, was an improvement over random forest as compared to the benchmark outputs. Okay, now I will quickly talk about one new topic on spatial computing. Then we'll try to end up in the session. So we had a nice, I think we had a nice session by Professor Shashi Shekhar from University of Minnesota, who also works a lot in the field of spatial computing. And spatial computing is a new area that is actually quite useful in different applications. Think about designing a smartest route, economical route, green corridor, or think about trying to use a Yelp, a TripAdvisor, or trying to book a Ola, Uber, or looking at an apartment through common floor, etc. So all of these applications use various algorithms for spatial computing. Google has done a huge amount of work in earth sciences. And Google Earth Engine is a cloud-based platform, geospatial processing platform, that has almost more than 5 million satellite images and are being used for numerous applications like change detection, mapping trends, identifying differences on Earth. So they have climate and weather data in the form of GridMet, GPM, global precipitation measurement, wall-to-wall imagery from Landsat, Sentinel, MODIS, and NAPE. They have geophysical data on terrain, land cover, cropland, and then they have data that have been used for global forest cover change, not only forest cover change, but numerous other changes. DMSP OLS is the nighttime data that people often use for detecting urban settlements. And then there are high resolution data to even map the aeroplanes, as you can see. Okay, there are other interesting studies going on. For example, deforestation, trying to look at the surface temperature change or climate change across the world. So, global forest cover change study was done by Professor Matt Hansen from University of Maryland, and this paper was published this few years back in the journal Nature. And all of them have been typically using Google Earth engine for different applications. Now, I will quickly show you some of the applications that we have been doing, our master student have been doing. So we had a project with CSIR where we had used drone data. The drone was flown in the University of Agriculture Sciences at Harvard district, and we had done some of the studies that I will present here. Before that, I'm showing you two related studies which focused on using machine learning techniques and deep learning techniques to detect potholes in the city. So our study area was electronic city phase 1 and the adjoining areas. And the two papers talked about different forms in which we can detect the potholes. So as you can see in the figure here, different pictures of potholes. Some are dry potholes. Fortunately, it rained that day. We also got images of potholes. And then each of these potholes were annotated using a hand drawing tool. Then techniques, mask RCNN and UNet were used to detect each of these potholes. So as you can see in the output here, different types of potholes and in different scenarios have been mapped. So we developed this in the form of an application and mounted this in a smartphone, and this smartphone was kept on the dashboard. And then in the real time, when we tried to move on the road, the algorithm was able to detect the potholes and show. So at some places, yes, we found that a lot of the garbage area or the waste, the areas outside the road also classified as pothole, maybe because we were not clearly able to separate out those garbage alongside the road along with the potholes. There is another video here where we try to discriminate the potholes essentially filled with water and in the form of mud. On a related study, we had done analysis of the UAV data trying to detect power lines, power cables, high power transmission cables in agricultural land. So the challenge here is that the power cables are actually present only in certain areas of the image, and most of the image part doesn't have the cable, the high transmission cable. So we have to reject larger part of training data, and it typically becomes a case of imbalanced classification. Currently, 2 members at our institute are working on dealing with imbalanced data classification. So a unit model was developed. As you can see in the sample at the bottom, there is a pole and there are 4 tables. So there is a one ground truth at the bottom and one estimated from the model. And these are some snapshot of various scenarios where we have mixed table mixed with green vegetation as a background. And in some scenes, there are no tables at all. And so we have the first column as original scene, the middle one as predicted, and the third one is the ground truth. On a related study, we also did work on crop classification using UAV data, where we had considered cotton, maize, and others class. And this is the last work that I will be showing in just 2 slides. So here the idea was that when we when we typically use deep learning techniques, we see that one has to generate enormous amount of training data. Now consider an application that we want to detect individual tree canopy from the scene, right? Typically, this would require more often than not huge amount of tree canopy data in the form of boundaries. Can we think of a way, a semi-supervised technique that can actually minimize the human effort of generating this tree canopy data? So here is an example of 4 different scenes which have a coconut tree distribution, and the idea was to detect these coconut tree and count the number of tree from the scene without much human effort and to digitize them. So I have just summarized the results in one slide. So as you can see, we first try to detect the visual tree through RetinaNet model, and then use a clustering algorithm to cluster the tree. But the challenge is that clustering actually clusters not only the pixels in the tree, but also the shadow along with the background. And that creates a huge amount of confusion. So we had used a thresholding based approach, and you can see in the figure here, in the figure 2, this is the actual RGB input, and this is segmentation. After applying RetinaNet, we do segmentation, then the tree is segmented. Finally, you can see the tree canopy being extracted from the, or more often I think we should use the term tree crown. Tree crown being extracted from the UV, particular UV scene. So we could separate out, identify individual trees and count them in every sample images. So this could be very much useful, especially in the deep learning area, where we want to minimize the human effort in generating the tree samples. But we have not yet tested this approach on other types of data, for example, LiDAR images or multispectral data. So there are several challenges which we encounter. For example, dealing with data. So because we spend a lot of time making the data analysis ready. So if that can be minimized, it would be a huge effort towards data sharing, and that also will minimize the redundant storage of the data. And then sharing of codes, intermediate results, workflows is still not very trendy. People do not tend to share the codes, especially, although now there is a great movement through GitHub where people have started sharing some part of the code, making it open source. There are several challenging areas where people can work. Visualization of spatial data in the form of different types of graphs, charts, and so on. Talking about big data and spatial science, developing scalable processing methods, advanced spatial analytics, geospatial modeling. Yes, of course, working on robust machine learning algorithms, which can be scalable, which can handle noise, and work with lesser training samples to higher accuracy. Handling multi-resolution, multi-temporal data is still a challenge. Deep learning in geospatial data analysis is still in its primitive stage and has to be developed a lot. And then use and promotion and use of free and open source software or geoinformatics or geospatial data is another collaborative area where people can work together. So with this, I would like to acknowledge all my supervisors and different guides who had taught me a different point of time, and would like to end the talk here with a special note of thanks to everyone for sitting quietly for a long time. And if time permits, definitely I can try to answer a few questions.
Yeah, thank you, thank you, Dr. Uttam. Any questions from participants?
Hello.
Yeah.
Hello. Yes. Thank you very much, sir, for your detailed presentation regarding the various algorithm. But like my question regarding the sub-pixel level classification in the context of supervised learning. So, like, sir, what is the difference between the MTMF algorithm and LSU algorithm, and which one is better in terms of supervised learning?
Sorry, I missed out the names of the algorithm that you talked about.
MTMF algorithm, mixture tuned match filter algorithm, and
What is
linear.
what is MTMM?
MTMF is a subpixel level classification algorithm.
Okay, and what is the what is the question related to? What is the difference between MTMM
Yes, and which one is the better in terms of linear unmixing and this LSU algorithm?
Right. So I thank you very much for this question. So I think some of these algorithms are available in softwares, especially NV and ERDAS Imagine, for example. So I have explored these algorithms. They are good when you are trying to handle smaller data sets, but when you try to deploy them on larger data sets, more often than not, they do not work very well, and also
Okay.
scalability is the issue. So an alternate option is to try to use the original concept and write a program, maybe in Python, C, C++, that would scale up for larger areas.
Okay, okay, sir. So, sir, can we like in big data, can we use the this algorithm?
Yes, of course. And I have shown you one of the examples that for the global data processing.
Okay, okay. Thank you, sir. Yes.
Any other? There is a comment question in the comment chat box. Can we classify different types of water bodies? In that case, which algorithms will be useful for this problem?
Yeah. So as I have experienced a little bit from experiments, so typically a multispectral data or not sufficient enough to classify different forms of the same class. Typically hyperspectral data, or maybe if you are planning to use a UAV that has multiple sensors in the sense that multiple division of the same bands, for example, red band and near infrared band, those data are really useful in the context of separating similar objects from one class. Maybe if you are planning to separate individual species of tree, hyperspectral data is really very useful compared to a normal multispectral data with medium resolution. Although you can definitely try something like Sentinel data, which has a higher spatial resolution with multiple bands, and may be able to help us to separate out. I'm not sure about the accuracy, but literature says that in such cases, tree species classification or separating water bodies, hyperspectral data have proved to be better.
Okay, thank you. Yeah, I have any other questions from our participants? Okay, that was a nice talk. I have one comment, probably like the opportunities and challenges which is available. Anyhow, the next talk and today another two talks are there regarding that. So you have given something about the pothole thing. So this was the idea which I have given to some of our students also while doing this machine learning courses. So yesterday, Professor Sasi Sekhar also mentioned some already in India we have this toll gate. So the Google will say like how the what is the minimum toll gate which you can go through if you are going in the highway from one city to another city. Similarly, Professor Sasi Sekhar also yesterday mentioned something about the greenhouse effect, like how to reduce the greenhouse effect, which way we can choose it. Same way, like in Google Maps itself, we can include that suppose the number of potholes are more in that area, then using the optimization algorithm, the shortest route where the pothole is minimum also can be implemented, where some startup can be worked out. So these are some of the opportunities which I could.
Yes, right.
Yeah. Thank you, Professor. So participant, if you have any
so
questions, let me know. Otherwise, I will thank the speaker. Okay. Thank you, Professor. Thank you.
Thank you very much, all of you, and have a nice day.
Yeah, thank you. So our next session will start at 11:30. Professor Lakhani will join soon. So please stay with us. Hello, Professor.
Hello, Bharat Lakhani, sir. Hi,
Hello,
sir.
sir. Good morning, sir.
Pancha, your voice is not
Okay.
clear.
Is
Actually.
it audible now?
Yes. Now it's up.
Okay. Okay, I will introduce the speaker. Good morning, sir. So good morning to everyone. Here with us, Professor Bharat Lakhani is there. He is a professor in IIT Kanpur. He's a professor of informatics specialization in the Department of Civil Engineering. He is working. He is also a co-founder of GeoAI India Private Limited, which is providing a highly accurate 3D and engineering solution for various projects, including public and private sectors. His research interest includes industrial activity in all domains like LiDAR technology. He also has kept many efforts in India for using LiDAR data for problem solving. So today he is going to talk about some of the advanced thing like how the India is growing in this case. Like the topic is geospatial technology, a ground for new startups and industry in the country. So the floor is for you, sir. Thank you.
All right. Okay. Thank you very much. So I will share my screen, and I guess my screen is visible.
Yes,
Is it?
Yeah.
Yes, sir.
Okay. Great. Thank you very much. So thank you very much, all of you at IIT Tirupati and Awadh, our student from IIT Kanpur, who is professor now there, and to give me this opportunity to talk about something on geospatial innovation, startup, and these related matters. So what I have done here, and I will run my story through my own journey in the startup which we did in GeoNo, and then I will also talk about a bit on the IIT Kanpur startup ecosystem, a very few slides. I will also take you to what I see kind of opportunities today. Of course, opportunities are many, but just briefly, and why this is the right time. This is the right time for one to go into innovation, startup in the area of geospatial. So that will be my goal. So as I said, yes, at the end of my presentation, we will be able to understand, yes, why in a university setup the startups are important, should be there, and then how in a university setup, because this is our story in IIT Kanpur, the startups can flourish. What should be done? What is the required thing? And it's for the authorities, it is for the student, it is for the faculty members, it is for all. Of course, then, as I said, I will try to take you to the GeoNo story also. And then finally, on the geospatial opportunities that we have today. So one thing that we find today, and this is the time, 1988 is the time when I graduated. I did my BTech. I completed my BTech degree at that time. And if you see, look at this, at that time, the most choicest options for people after their graduation were, you get into PWD, Public Works Department, get into the state irrigation, or get into the Indian Engineering Services, ISRO, DRDO, the public sectors, or maybe, you write IAS or IFS, or, well, you can also do MTech, like I did MTech at the time. Instead of going to any of these, I chose to go to MTech and then PhD. And private companies were at the last, at the bottom. And at that time, nobody was talking of the startups actually. That was really interesting time. Nobody was talking of startups. People will talk of these things. All the time when we are in the college, we are talking about these possible opportunities. We're not talking of the startups. But now today, in 2022, the things have changed. And if you look into this, the priority wise, our students today, they talk of a startup as the #1 priority. whether they want to start or whether they want to join. In either way, our young students, they prefer to go to the startups because the startups, they give some kind of challenge. Then yes, after startup, our students, they are looking for now consultancy, analytics, finance, IT. Then comes the private companies, and all these IES, IS, ISRO, DRDO, they come towards the bottom of the pyramid in the priority. And of course, yes, there are some people, very few, who are keen, they pursue their MTech, PhD, and state governments, of course, have become the last priority. So this is the fact. This is the fact today, because this is what is happening all around us. Now, in this scenario, the startup or the university spin-off is the buzzword now. Now, of course, it's not for only youngs. I always say this, startup is not only for the youngs, because sometimes we start connecting a startup with the youngs. It is not so. It is for youngs who are in the university, who have just graduated from the university, or 1, 2, 3 years in the job and still young and want to start. But it is also for middle-aged persons, from the industries, from the universities. When I started my company in IIT Kanpur, I was in middle 40s, and that was the time we started our company. Of course, I had a very young, dynamic partner with me. So together we started our company. Then nowadays things are changing. Even many retirees are going for the startup, because the ecosystem in India today is ripen for the startup, and the investment is coming to the startups. The government is providing all kinds of supports. The market is recognizing the startups, and besides this, even the IT technologies, the way the cloud technology is there now, with very less investment in the capex, a startup can start his business and can start providing the solutions. So there are startups which are just running on the OPEX model instead of the CAPEX model, and I will talk of that also later on. So overall, the scenario, the ecosystem is very positive today, and all kinds of people are going for this. Well, one thing we always say is, why startup and why not these old companies? Naturally, startups are very important because they do not come with any inertia. They don't carry any baggage like the old companies. They have a certain agility, and of course this latest fresh. Okay, and generally they don't have much to lose. They can take the risk and can experiment. And those who are involved in the startup, they take ownership. In a big company, the ownership will be taken by few people, but in a startup, there are few people, and all these people are related with the startup, so they feel associated, they take ownership, and that is the reason for the success. Then yes, because in a startup, you have few people working in a new idea, and so you're working highly, passionately, and you have a desire to learn, and even in the case of the ambiguity, still you have that ability to thrive. Okay, and mostly in the startup, because you are associated, as I said, you feel ownership of the thing, so you put the company before self. And a startup, of course, is open for the collaboration, and these are the things why startups do succeed or come up with new technologies, come up with the technologies which otherwise an old company, an established company, will not dare to get into, because old companies generally they have got a lot of inertia, they have got a lot of baggage with them. So for them, the agility is missing. And of course, I'm not painting all the old companies with the same brush here. No, there are old companies which still go in the startup mode. So if you come to the university setting now, because we started our company in IIT Kanpur, so why the university spin-offs? And the good thing today is, in India, many IITs, many NIITs, and many other colleges, they have their startup culture. They have a system within the institute where the startups can be, initiated, and a team can start working within the college environment. So that is there. So the other reason that many times in the university, we develop the technologies or we do research, but the research that we do many times it is only for writing the paper. Once we write the paper, we forget about it. Okay. However, if that paper or that technology or that research which was done in the university, it goes into the startup mode, then it will come up as a full technology which will finally make impact to the people. So instead of going just as a research paper is good, it should be there, but just writing a research paper, instead of that, if you are filing the patent, or more than patent actually, if you are converting that patent, converting the research into a technology which is ready to go to the market or which is going to the market, then it offers this commercialization scope of the university technology. And another thing, as I said, in universities, we have this freedom of working in high risk areas. Because in a university environment, within the academic environment, we can always work, we can always take the risk. And because in the case of the research, when you're doing the research, we take it as granted that my research outputs can be positive or can be negative also. Because the negative research output is also a learning. So the university setup provides this opportunity that we work in high risk technologies areas. So once we succeed in this, there is now this scope of commercializing these technologies, taking to the market. As I said earlier also, young students, they always prefer to work in the spin-offs or the startups, because they in their language, they get the kick there, because they get that excitement of working and being associated with something new that is being developed. So for that reason also, the university spin-offs are the best place, because you can hire the students from the universities or the institutes. On the other way around, if you are running your startup in the university environment, you are involved with the industry in the university environment, it also helps in quality of the instruction and the research. But many times otherwise, we become very, very theoretical in our research. So many times I say, and to the funding agencies also, I recommend, and it is happening now slowly, that the research that we do should not be only a theoretical research. Rather, there should be some impact that can be made by the research in terms of a product or in terms of directly reaching the people in some way. So you will notice now that many funding agencies nowadays are asking you to have a kind of business model for the research that you're doing, because the research that we do for research paper, yes, perfect, the research paper should be published, but at the same time, how many people the research output can impact, that is a very, very important thing. So I say this, research is not only the impact factor that we always look forward to, rather it is also societal impact. The work that you have done, is it really able to make impact into the life of the people around you, in your society, in your country, across the world? So the university spin-off, they help us to learn the challenges of the field, the challenges which are there in the within the society, and so we start doing the research in those domains. So that way, as I said in the previous screen, the university spin-offs are very, very important. However, I always write this, I present this slide, and that's an Indian paradox. And Indian paradox in case of electric industry, because I'm emphasizing this point that we should do research and take it to the market. That is what I'm emphasizing in any institute, in any research lab, or in any university. But there is a paradox, and the paradox is this. The paradox is the goddess Saraswati and the Lakshmi, they do not meet. They always sit over these two ends, because Lord Ganesha is always sitting there in between. What do I want to emphasize by this? Goddess Saraswati is the god of education, learning, knowledge, while the goddess Lakshmi, we say, is the goddess of wealth. And generally, this is true across India, that knowledge, we think, or rather we take it as a taboo, that in university setup, the knowledge that we generate should not be related with the wealth. And that is considered a taboo in India. It is changing now. It is changing. So this profit, the word profit as such, is a taboo in the stage. And that was more so when we started our company in 2009 or before that. So I think this mindset is changing. This is why the startups, the innovation, and taking the technology research to the market is being promoted across all universities. So this paradox is slowly going away. While abroad in the West, this has not been the case. This paradox is not there. A company being started by a university professor was very common there. So we are also learning that, and I think this is good that this Indian paradox is slowly going away. So at this stage, as I said, this paradox is going away. So the writing on the wall is very clear. In what sense? Because across the government hierarchy, in the universities, in the society, in the market, it is being realized that the universities, institutes should become a place of developing technologies, okay, innovation, developing technology, developing product. And I will tell you, in IIT Kanpur, we are going to have our new UGRC and the PGRC. So over 1 decade time, we design our course curriculum. And for the postgraduate, for example, we are saying that the MTech thesis, it should lead to the research, it should lead to the research publications, perfect. But at the same time, we are also saying, no, an MTech thesis should also lead for the development of a product. And this product development can be while we work along with the industry. So this is what I write here, writing on the wall is very clear, that this necessity is being realized everywhere. And lab to industry has become a need. And because of this, now you might have also seen it, the government is emphasizing on more applied research and the product development. There are many opportunities in the government of the research funding, but in all the research funding now they are asking what is the commercial aspect of this. They are also asking whether the research that we are doing, whether it is being done with an industry partner or not. You might be aware of the 2+2 kind of funding. 2+2 is when a university and an industry from India can collaborate with a university abroad and an industry abroad. So that is 2+2 kind of schemes. Many of those schemes are available. Also, the university and the research labs, they are also expected to earn now the revenue, because the government funding will not be coming as it was coming earlier, because our university, our research expenditures are increasing, but at the same ratio, the government funding will not increase. So what will happen? From the research that we do in the institutes, we are now also expected to earn the revenue, either by filing the patents and then transferring those patents to the industry, or by the startup. So overall, this startup culture within the university setup, and as well as, of course, elsewhere, it is spreading now. And we see there are so many opportunities for the startups. And this is why I say there are so many opportunities from the government, from the public sector, and it's a very positive environment today for young people or all the people, all the faculty members or anybody to get into the transfer of technology to the industry, or developing their own startup and taking the technology to the market. So the time is really right for this. Now, in this case, just few suggestions from a side that what should an institute do? Once we have this background, the institute should do is creation of an incubation facility. And this is really important. And I recommend this for all engineering colleges or all universities, that they should have an incubation facility, because a platform is really important. And more important is a very positive policy framework. So the intellectual property which is being generated, we should have the policy framework, how to protect it, how to do the tech transfer, and more facilities for startups by the students or the student faculty combined, or only the faculty. And this incubation facility should provide the facilitating environment. It should be an enabling environment for all the people who are working, whether it is students, student faculty, or the faculty only, so that they don't much bother about the nitty-gritties of starting a company, going for the funding, and writing the business business model, and so on. Rather, these things should be facilitated, and so that the core team of the students, faculty, they focus rather on the technology development. So at the same time, yes, the institute should also promote the applied research, and the applied research for solving the local problems. And I will cite one example here, a very good example. And this is something, when from IIM Ahmedabad, Professor Anil Gupta, who has the Innovation Foundation, you may be knowing about him. He had come to IIT Kanpur, and then he delivered a very good talk about the grassroots innovations. So at the end of his talk, one of our students, he was in third year electrical engineering, and then he stood up and he said, "Sir, I'm very good in physics, mathematics, chemistry, computing, electrical engineering. I'm very good in all these, but I do not know which problem to solve." So this is really that was a very important question. And why this is an important question? Because our student is not exposed to the problems, the local problems. So I see this, there should be the possibility of students, faculty, and others interacting with the locals. Because which problem to solve? There are so many problems to solve. So many problems to solve. Which problem is really important to solve? We should be very clear on this. Because once we find which problem we are solving, okay, this is really very important for any startup. Once this is very clear to us, other things can be managed. So another thing which I say that within the institutes, we should promote the participation of undergraduate students in the research and in the research leading to the startups. And this also I say, because say in any institute, there might be 6,000 to 7,000 undergraduate students, or maybe say 10,000 total number of students, or more than that, whatever the number is. That's the time when they are quite innovative, when they don't carry any baggage with them, when they don't have any inertia. So they have very fresh ideas. So institutes should do this, that they should promote involving them in some kind of the research. Again, I will cite the example of IIT Kanpur here. In IIT Kanpur, we have recently started a policy where we are permitting students to take off from their usual academic load. Okay, so in any semester, the students will register for, say, 60, 70 credits. And that means 5-6 courses they will register, and they will have to do those courses. But now IIT Kanpur is permitting them, okay, they need not to register for any specific these courses which are there in the template. Rather, they can also register for the courses which are on innovation and startup. So for 6 months, for 1 year, a student can focus on a certain idea, and he will be mentored by the faculty members. And of course, there is a way of how to manage this entire thing. But we are facilitating students to register for innovation credits. So during that 1 year period, the idea why are we doing it? We want to do it so that we don't want students to wait till they graduate to start their company. Rather, in their third year, in their fourth year, whichever the year, they have an idea, they want to work on that idea, they have a team, they can take off from the usual courses, they can register for these innovation credits, and then start working on their idea and incubate their company. So the idea is we want them to incubate their company early on, and then later on take it to the market. So I think the institutes like in IIT Kanpur we need to come up with these innovative ideas to promote this research. And of course, last year, any lab to industry or spin-off efforts should be rewarded by the institute. This is simple. Now, what are the possible models? Yes, sometimes we develop the technology, we transfer it to the government and private directly. or alternatively, we can go for the startups. And startups, like in IIT Kanpur, we have this model: a student can start their company, a student with faculty members can start their company, only faculty members also can start their company. Also, we have any person who is outside IIT Kanpur. He can also come to the IIT Kanpur Incubation Center and start his or her company. Now, one more thing here, and this is related with our academic research and what level of efforts we need to put so that we can take it to the market. So we are aware of this term, the technology readiness level. And first, the academic research that we do, academic research is limited to TRL 2 and 3. So basically, we are doing the basic research and we are trying to prove the feasibility of our algorithms, feasibility of our tool. So academic research generally goes up to this end. And at the end of it, we write a research paper and we move to the another research. However, the requirement is that we do not stop here, because in order to take the research to the market, the journey is longer. So what should be promoted? We should promote rather taking the development to TRL 4 to TRL 6. So TRL 4 to TRL 6 is something which can be done within the incubation environment in the academia. Like we are talking about this students taking an idea, developing a prototype. So the technology development based on the research and demonstration of the prototype, these can be done. And this is something, TRL 4 to 6. This can be done within that academic incubation environment. Again, the journey doesn't end here. Rather, the most difficult part is because many times, we take the technology up to the prototype and we demonstrate the prototype successfully. But to take that prototype, take that technology to the market, the next couple of steps, the 3 steps are very important. And this is where special efforts are required. So these special efforts, because now we have to create ready to market technology. How to take it to the market, and what will be the costing of the technology, why people will buy this one, what are the competition, and so many other things will come in picture over here. So this TRL 7 to TRL 9, it requires very, very special emphasis here, which should be enabled by the academic institutions, again through the incubation environment, or if we are not going for the startup, rather we should collaborate with the industry so that whatever the demonstration of the prototype that we have done can be taken to the industry once we work with the industry in these TRL 7 to TRL 9. Okay, so having said that, very briefly, I will tell you about the Juno story. And this name here stands for geospatial knowledge, because we started from IIT Kanpur, so we wanted knowledge there. So geospatial knowledge. And so, as I told you that I did my BTech in 1988, and 1990 I did my master's from IIT Roorkee. And at that time, when we would do survey, and I think some of you are exposed to the survey. Once we do the mapping on the ground, at that time we were using the theodolite or plane table survey. So very, very rudimentary technologies. Nowadays, we can say rudimentary technologies. And at that time also, I used to think whether there will be some robots in the future who will be able to do survey. Because the effort was too much in the field and no possibility of automation was there in the case of the theodolite or the plane table. So this thought was always there in my mind. Then in 1999, I completed my PhD in the University of Reading. And at that time also, initially I was working with airborne thematic mapper. In 1996, I started working with the airborne thematic mapper data for geomorphology. At the same time, in UK, the LiDAR technology came. And we also received some data from the LiDAR of a coastal area. So there was a dichotomy, okay, with me, should I continue to work with the ATM, airborne thematic mapper, or should I move to the LiDAR? And in that confusion, in that predicament, my supervisor, he told me a very nice thing. He told me That, and why he told me this? Because ATM was not giving us good result, while the LiDAR would directly give me the 3D. Okay, ATM, we were trying to generate the 3D using the ATM data, but LiDAR is directly giving you the 3D. So you can straight away use the 3D from LiDAR and you can move to the geomorphology. So when I discussed this confusion with my supervisor, he told me, okay, you join the competition if you cannot beat it. So we knew that with ATM, we cannot beat the competition. So I joined LiDAR. I started working with the LiDAR. So around 1997 onwards, I started working with the LiDAR. And yes, LiDAR technology, we know it. What it does, it will give you the very good 3D data of whatever you're observing. You may be observing a very small thing, okay, within the industrial environment. You may be observing the human-sized artifact. You may be observing this room, or you may be observing the terrain from the drone, from the helicopter, or from the aircraft, or maybe from the satellite also. In all these cases, the LiDAR technology gives you wonderful, accurate 3D data. Okay, so I started working with that, and then yes, I completed my PhD, came back to IT Kanpur. So I was in IT Kanpur, yes, doing my teaching and the research. But at the same time, I also focused on this part, the development of the technology, products, and patents. And I was frustrated around this time when I joined IT Kanpur 2002 to 2009. I was frustrated in the sense because there was no LiDAR data in India, and getting LiDAR data in India was very, very difficult. And as we will see in my future slides, LiDAR data in those times, it was considered to be highly classified. You cannot capture it, you cannot share it, you cannot pass on to your student. So it was a lot of frustration at that time. And there was no company. I used to talk to the companies, okay, that why don't you start, why don't you invest? But no one was ready to capture and invest because these data were considered classified data. And they knew that if they go to the market and start investing into it, maybe they will not be able to generate revenue because the data is considered highly classified. So there was no data for my students to work. And also there was no awareness of the LiDAR. Okay, and people were quite happy using the traditional methods of surveying to do their work. So there was no awareness among the users also. And around this time, of course, I did one thing. I developed a LiDAR simulator. In 2006, 7, 8, I developed the LiDAR simulator through which we can mathematically simulate the LiDAR data. And we are still working on that because there is some other interest that we are pursuing, very important interest. So anyway, this frustration at that time, nobody was capturing the data in India, nobody was developing solutions in India. So we saw this as an opportunity. And 2009 was the time when I had my colleague and my partner, Balaji, who joined IT Kanpur in 2008. And together we thought, okay, fine, let's do something. And we started our company in IT Kanpur under the faculty entrepreneurship policy. And as I said, we have a very good entrepreneurship policy for the faculty members in IT Kanpur. And because of this policy framework, I could start the company. And of course, the company did many things. And at that time, this used to be our logo. And of course, now we have moved to a new logo. And from 2009 to 2012, yes, I had to prepare the team, train them in the technology, and do all those things. And of course, we did some very challenging projects using the terrestrial laser scanning. And we got very good feedback from the clients. So we realized that how and why people will move from their traditional methods to the new methods. So we realized this. And with this, we started our company in 2009. And around 2012, we faced this question. And that's the question, all startups, they face it. What is good? Owning a small cake is good. You're owner of the whole small cake, or you want to own a small pie of a large cake. Okay, you know the answer of this because Narayan Murthy, who is the founder of Infosys, he owns a very small pie, but the cake is very large. So we also faced this question at the time in 2012, and we thought, okay, let's make the cake large. and own a small pie. And we joined the GMR group. So our company GNO became a subsidiary of the GMR. And then, yes, since then, a lot has been done within the company, and company, is a leader in the LiDAR technology in India. It operates all kinds of platform. It is the terrestrial platform, mobile platform, aerial platform, in aerial drone platform, helicopter platform, aircraft platform, and has captured now around 70,000 square kilometer of the aerial data and 20,000 linear kilometer of the mobile data, and around 150 successful projects. So a lot of work has been done in this. And of course, this list is of the clients and the projects. So a bit about the setup and our team, which is on work. And while we are capturing the data, we also focus on developing the solutions based on the data. And so, for example, we have the rooftop solar potential technology now, because LiDAR data and the photograph that we do, with the help of that, we can predict the solar potential of all the rooftops in an area. So we have our technology for that. Using the terrestrial LiDAR and the mobile LiDAR, we capture the data of airport, and using that, we develop the solution which is used for managing the airport affairs. Okay. Then airport obstacle survey. Again, yeah, that was something which was being done traditionally earlier. Now we are using the LiDAR technology for this. For construction monitoring, flood modeling, inundation mapping, irrigation planning, and so on. There are several technologies or the solutions were developed on the data. And of course, I'm not going to go to this particular video, but if you are interested, you can search in the YouTube. And our company has done a wonderful work, which was from Mumbai to Ahmedabad, the FLS survey of this entire area. And the National High Speed Rail Corporation, they liked the technology, they liked our solution so much. Now, many high-speed corridors in India are being done by the same technology. So that's the list. And of course, there are so many things that the company has done. And for me, the most satisfactory thing is that by introducing LiDAR technology in India, and by developing the processing methodologies, the ground survey methodologies, and combine system and training the people, and because we have 100% Indian team and Indian expertise, we were able to stop the entry of foreigners who wanted to do LiDAR technology in India. So our team was able to do that because we are providing that solution. My another satisfaction today is that we are employing 100 persons directly who are on the roll, and of course, at any point of time, 200 more people are being employed indirectly. Okay, and then yes, impacting people, good impact in different kinds of projects, very important projects. For example, one I would like to show here, that is in the inland security. The many inland security projects have been done in the areas which are affected by the Naxals using LiDAR technology, because LiDAR had this advantage that it can penetrate through the trees. So it has that possibility, you can view the objects, the targets under the tree. So we developed this technology and have done a couple of projects in this, and that is going to be done now at a larger scale. So that was the satisfaction, that the technology could go to the people, could make the impact. So as I kept on telling you that in IIT Kanpur, we have a very good and a vibrant innovation system, startup system. And so anyone who wants to start her company can come and, in contact with our, this is called Startup Incubation Innovation Center, and they provide you all facilities so that you can start your own venture. And of course, there are many more to discuss on this, but I'll not get into it because these facilities, they provide you a platform where they provide you a good address, they provide you the funding possibilities, they help you with the registration of your intellectual property. So all this is possible here. Now, having said that, I will briefly touch upon the geospatial opportunities. And this again, few slides that I just added right now, and but I will try to give you the flavor. And all of you may be aware of this very important development that on 15th February 2021, India released its new geospatial data policy. Now, it's a very important thing, very important for the startups. And I say it as a watershed day for the geospatial community in India. Now, why it is so? Before this date, as I told you earlier, the LiDAR data, photographic data, high resolution data, satellite data better than 1 meter, all these were considered to be classified. If you want to procure the satellite data, you have to go through multiple channels of permission. If you want to capture the LiDAR data and you want to fly your equipment, drone, or maybe your helicopter or the aircraft, you have to go for multiple levels of the permission. And in general, at that time, it would take 6 to 8 months, 1 year also, just to take the permission. See, what is the USP of the LiDAR? The USP of the LiDAR technology is highly accurate data, very dense data, complete capture of the area, and the most important USP is very fast. Because I can fly 400 square kilometer in a day. So I can capture 300 to 400 square kilometer data in 1 day. That is possible. But if I'm putting my 7 months, 8 months, 1 year in just taking the permission, what is the use of this 1 day? Okay, so that was a big bottleneck. So that's why I called it a watershed day, because since that day, when the geospatial data guidelines were issued, an Indian entity means anyone, an individual, a company, government department, university, anyone, whatever the Indian entity is there. Now it is free to capture, process, disseminate, develop solutions using geospatial data of any accuracy. So today you can capture the data of any accuracy, okay? And the permissions are not required. Yes, you have to take the permission. If you want to use the drone, to fly the drone, you need to register your drone. To fly the drone in green zone, you need not permission, but to fly it in orange or red zone, you need to take the permission. Similarly, in aircraft also, to fly my aircraft, I need to take the permission from DGCA, or maybe because DGCA would like to check my aircraft, whether my aircraft is worthy of flying or not. Similarly, DGCA will check your drone, whether it is worthy of flying or not. So those permissions are required. But flying over the area, you don't need any permission from Ministry of Defense now. So straight away, if my permission is available for my helicopter, for my aircraft, from a drone to fly, I can go to any area, fly, and capture the data today. So this is really unbelievable, but true. And I'm writing this because we have seen the times which were before 15 February 2021 also. And that's why I call it watershed day. Now, the another statistics here. Once we have this free market or no regulations, and of course, one more thing that I would like to address here, and it is important if you're looking for a startup in geospatial, that point is very, very important. As I said, Indian entity is free. But at the same time, in order to nurture the Indian innovators, Indian startup, what the new geospatial data guideline has done, it says that the foreign entities cannot capture data better than a certain threshold. So whatever the data today is being captured by foreign people, for example, from the satellite, they are capturing more than 1 meter resolution data. They can continue to do that, but they cannot capture in India data better than that accuracy. So these accuracy values also, the threshold values, are going to be published by the DST soon. Now, what does it do? The moment the foreign entities are out of this data capture business, suddenly there is lot of market that opens for Indian startups or the Indian companies. And this market is going to touch 1 lakh crore by 2029. So this market is going to grow at 13% CAGR and will be 1 lakh crore market by 2029. So it's a big market that is going to open up. And that's why I say, no, there are opportunities now for the startups. Now, briefly about startups. If you are in this mindset, okay, yes, I have to do something, I want to start something. So just few things from a side, few things. First, on the data generation part. Data generation, as I said, in India, we have very good quality Survey of India maps, but they are at 1:50,000, 1:25,000. We don't have large scale maps of the entire country. Also, if a map was made 10 years back, unless we update the data, the map will expire because the ground is changing. India is a developing country and the things are changing very fast in India. Out of our 32 lakh square kilometer, that's nearly is the area of India. Only 4% of the India has been mapped with LiDAR data so far, or I will say high resolution data, which produces large scale data or large scale maps. So around 95% of India is yet to be mapped. Well, the question will be why 95% of the area should be mapped with high resolution data? Yeah, that's a very valid question. But if you see across the world, entire USA has been mapped with LiDAR data. And they did it because there is requirement of that data. So for India also, we need it. Maybe very high resolution data will be limited to cities or those areas which are economically very, very active. But rest of the India also will need to be mapped with good quality LiDAR data or the photographic data. And there is a lot of scope for this. So there is a scope for the aerial platforms. You have the aerial aircraft, you have the helicopter, or scope for the drone. And the way the things are happening around the world, it is being recognized that when we fly, we should fly both the sensors, camera and LiDAR. Because camera gives you the spectral information. Okay, the camera can be RGB and infrared. So camera and the LiDAR, or maybe a multispectral sensor and LiDAR, or maybe hyperspectral sensor and LiDAR. So that we call the hybrid. Because though I can generate the 3D geometry also with the camera images, but those data have limitations. Okay, that's why the LiDAR is being used here. So across the world, the modern way of capturing data is now this hybrid approach where we fly both camera and the LiDAR. So there is an scope in India to map 96% of India now with this kind of sensor. So it's a big area for the work. Another one on the data capture. So this is also again data capture. I'm talking about those opportunities which are in geospatial data generation. We all know, what is the meaning of the last mile connectivity. The last mile connectivity is if you are waiting on left side of the road, say, and you ask the Uber to come. So many times, it happens if your location is not correct in the Uber map, the Uber person may go to some other side. Okay, and it has happened with me also. There is a boundary wall. I'm standing here. I'm giving my Google position. He goes on the other side of the boundary, and he's here now. Why? Because the maps which are being used by Google or maybe Uber, Ola, or any of these companies, or not only that, the companies which are in the supplies, for example, the Amazon, Flipkart, they don't have yet good quality maps for the last mile connectivity. Going from one city to other city, going from one part of the city to the other part of the city, yes, currently the data is good. And we can use the Google Maps, we can use the Bing Maps, we can use the other data sets. But once you are in a certain locality, okay, and now I want to reach a certain door. So I cannot reach that door. Okay, so that is not possible for me. So that is not possible. So that is what we call the last mile connectivity. Okay, no, again, So we call it last mile connectivity. So there is a lot of scope to generate these last mile connectivity data in India. And the good thing is only Indian companies can generate this data. As I said, because this data will be of accuracy better than 3 meter. Okay, and any data better than 3 meter accuracy, and so 10 centimeter, 15 centimeter, 1 meter, 2 meter, these can't be generated by the foreign entities. So that's why there's a big opportunities for this. Another opportunity which is there in the mobility sector, and this is about the high density maps of the Indian roads. Yet we don't have the high density maps. Very few maps are being generated and are being at experimental stage by some companies, because for automatic driver assistance system, okay, that is one level of automation in the driving, while the next level is driverless car, okay, so AV vehicles. So in these they need the high density maps of the Indian roads, and yet we don't have those. So there is opportunity to generate data for this. Another big opportunity which is not yet there, but abroad lot of indoor mapping is happening. The moment I say indoor mapping, the meaning is in a hospital, you might have faced this problem. If you go to a mall and you want to go to a certain shop, how to locate it? It becomes very difficult there, because yet there are no indoor maps. And so many malls have been created, so many hospitals have been created, so many colleges, institutes have been created, so many big, large 5-star buildings are there, okay? And yet we don't have the indoor maps. So the navigation within those buildings require the indoor map. Not only that, in the case of the disaster, okay, if there is a fire in a building, the fireworks department, they need the indoor maps, because then they know where to go, how to negotiate, how to manage the fire. Okay, in case of, say, for example, some terrorist attack in a building, if the security agencies have got the maps of the indoor, then only they can plan their activities. So there are large number of applications, and it is said, we were talking of the outdoor maps. It is said that the next big opportunity in geospatial is the indoor mapping. And abroad, a lot of work has started in this. I know the companies who are investing hugely on this, and a friend of mine is working in a UK company in this area, and they have now around 1 lakh properties, the buildings, their indoor maps with them. Okay, and also when we talk about, you may be knowing about it, the Facebook is talking about the metaverse, and the other companies, Nvidia and others, they are also talking of that. The metaverse means we are trying to create a digital twin of our physical world. The digital twin is of the outdoor, so we call it, the 3D city models, and digital twins of the indoor also. And why so? Because in future, once we are going to the metaverse, once we are going for AR, VR applications out of metaverse, we will need to create the indoor maps, the 3D models of the indoors, for that metaverse concept to be successful. So this is why there is a lot of scope in this. And I'm aware of Facebook, because of a friend of mine, he works there. They are generating a system which will be something which you can carry on your back, very small mapping system. And as you walk in the building, through SLAM, the map of that entire indoor will be generated. And of course, once the data is collected, map is generated, then you are making that map in a very light form, okay, in a vectorized form, you are storing it. So this indoor mapping is also a big opportunity in India. And anyone who is looking for the market in next 3-4 years kind of time, okay, that's the area. Another opportunity, and this is really big scope, and many smart startups in India have made have profited out of this recently, because we know there are large number of free data sources now. We can talk of Bhuvan from India, ISRO, USGS, the Sentinel data is available, the Google data is available, and of course there are many more sources of free data downloads are there. So slowly it will also happen, the data will become commodity. Okay, the data capture techniques be commodized, right? It will not be a very difficult thing to capture the data. A lot of data will be captured. And today also we know a lot of data we are capturing through our mobiles and which is being housed somewhere in some servers. And these data will also become available. Many of them are available. For example, say the Central Pollution Control Board, they have their pollution monitoring stations across India, and that data is available to the public. Okay. Similarly, large number of these data are now becoming available in the public domain, which was not there earlier. Now, with this data being available, what are the opportunities now? The opportunities are of the data analytics. So can we use these free data and our learning of the geospatial technologies and develop innovative solutions? And even you will notice that there are many free softwares also, which are available. The new thing that is coming now, because once we are going to the cloud technology, a startup, they need not to invest in the capex. Okay, they need not to invest in buying high capacity processing machines or some very expensive software. Rather, these are also available on pay as you use basis. For example, so I say you can now acquire the compute or the compute power and also the software in OPEX model. Okay, not in the CAPEX model. So for example, there is a wonderful platform, Nebula Cloud. And that cloud, Nebula Cloud is an Indian platform and created by an IIT Kanpur alumni, Venkat. So this platform provides you the access to any kind of compute requirement. For example, if you are doing say deep learning, and in deep learning, you want to train your model. To train your model, you need 64 GB GPU. Well, you don't have that machine. That machine will cost you 20 lakh. So how to manage it? Rather, you go to this platform and immediately within a couple of buttons, you can now access that machine and you start processing your data there. So you pay to this machine only for the time that you use this machine. Also, for example, I want to do some processing on ISRI software, but I don't want to buy it. I can use again the ISRI software or many other softwares by going to this platform. So I'm using now the compute as well as software technologies from a cloud platform. Okay, so this makes moving into technology development for startups very easy because you don't need that investment in the beginning. Okay, so you rather focus, and there is also one more advantage of this. Once as a startup, we invest in machines, software, that needs a lot of hassles because you have to do the purchase process, you have to buy the right thing from the market, and you have to negotiate the cost and other things. Then also in-house, you have to maintain it. Or you might like to, appoint a person who is managing your IT infrastructure, who is managing your software licenses. So, but once we move to a platform like Nebula Cloud, all these things are not required because all these pains are taken by the cloud provider. Okay, so overall, what I'm trying to say is with the availability of a lot of free data, and these data are being captured by different satellites, different sources on a very regular basis. Okay, also we have the system of the cloud where we can develop the technologies, process this data, and using this, we can provide solutions. Now, there can be a number of possible innovative solutions. Okay, I'm just giving you just few. For example, say crop irrigation requirement. We have the weather data available. We have the rainfall data available. We have the soil moisture data available. We have, the land use data available. All these data available. By combining all these data, it should be possible for me that I can advise a farmer whether he should irrigate his field or not. Isn't it? Because see, if a farmer irrigates today, but after 3 days there is heavy rain, so that irrigation is not required. Okay, so just for this kind of problem, crop irrigation requirement, I can provide this advice to the farmer on his mobile. And systems like this are being developed so that a farmer takes an informed decision. And it is good for the environment because we are not wasting water. At the same time, it is good for the farm. Okay. Similarly, in India, as you know, we have this Pradhan Mantri Krishi Bima Yojana. Okay. So this crop insurance, any company who is into the crop insurance would like to know about the status of the crop, okay, at different stages. So how can we do it? We can do it using the data which are available for free. I know of a company, again from an IT Kanpur, our student, who is trying to develop a technology to assess those people who are in carbon credit assessment. Okay, if I have some area which I have put under the forest, how much carbon sequestration can take place there? So how many carbon credits I can earn? Because you know the carbon credits are being traded now. So before to trade the carbon credits, we need to establish the carbon credit. So he's developing the technology on this line. Again, he's not using any commercial data. He's going to this data and trying to do with this. Okay, commodity is a big market. And in commodity, we know the prices, they fluctuate. And this depends upon how the commodity in the field is behaving and how the crop and other things are there in the fields. So again, by taking the observations from available data, it is possible for making predictions for the commodity market. There is a company and an IT BHU graduate, she has started that, and a very good company. And the companies, they are using the data available in public domain of the air pollution. And using that data, they are generating a couple of analytics. So the important thing is, there is a lot of data, but the data in itself is not good. Okay, naturally, because we can't do much with the data unless we generate some analytics based on the data. So this is really a very, I will say, important area. And if you have good fundamentals in data science, in remote sensing, image processing, GIS, and so on, then going to these free sources and these OPEC sources, you can develop the solutions, and these solutions are very much in demand. And recently, you might also remember, Ola acquired a company, Spoke, I believe the name is Spoke, and that company was doing the same. In 2015 or so, that company was started. And then recently Ola acquired that company, and that company's model was similar, okay, using available data, and they were trying to generate the analytics. Another thing which is happening, and in future, a big scope for the startups. There are some big companies in India who are going to invest in capturing the high resolution data of Indian cities. Okay, so there are already few cities that have been done. We have done a couple of cities, and now this data, say currently they are targeting, say Genesis, for example, they are targeting around 125 cities in India, and they will capture the high resolution data of those cities. Now this high resolution data, photographic data and the LiDAR data, I know Genesis in itself will not be able to monetize this data fully, because the data has so many possibilities. So these big companies like the Genesis or others, they will make these data also available to the public, available to the startups who want to use the data and generate some analytics based on the data. So that way, the startups, they also earn. At the same time, the company who has invested in data generation, they also earn in that process. And of course, at the end of the day, they are adding value to the society by providing those analytics. So, you might be aware of the term gig economy. Gig economy means, me sitting in my place, using, without working with any company or so, we also call them as freelancers. So freelancers are going to work in these models a lot. Okay, a freelancer can be, one person, can be a group of people, a very small startup, sitting somewhere where the internet is available, can utilize these and can provide the solutions. So this is really very, very important thing. Well, to conclude, as we said, yes, startups are important. They help economy. And from our institute research to the startup, is very much required, and there is positive environment in the country. So for those who are thinking in this direction, they must take this step now. And there are so many opportunities for funding. Recently, you might have seen many drone companies who were started 3, 4, 5, 6 years back. They are getting good funding from the investors, because there is so much of publicity about the drone. The Prime Minister is talking about the drones. So drones for mapping in geospatial, drones for irrigation, drones for agriculture, drones for delivery, drones for other applications. So why I'm saying this? Because there are investors who are looking for these new technology areas, and because of Indian geospatial system being deregularized. I'm again coming back to that date of 15 February 2021. Once the Indian entities were made to were completely made free to capture data, process data, disseminate data the way they like. So since then, there are so many opportunities, and the investors are looking into these. Those investors who are not investing into geospatial so far because of those earlier regulations, restrictive regime of the past, now they are coming into the geospatial, and they have started investing into the geospatial in India. So I think yes, starting a company in geospatial is the right thing to do. And if any of you have got any idea, yes, please go ahead. And if you want to discuss with me further, welcome. You want to come to IIT Kanpur, start your venture, welcome. Well, thank you very much.
Thank you, Professor, for the detailed presentation about the opportunities, especially the startups and other things, and also elaborative discussion about Geo. Any questions from participants?
Well, this is Srinivas, who is the CEO of Navishkar I Have Foundation. Dr. Bharat, we worked together for quite a long time as partners, colleagues, and competitors and all. Because similar lines, 2009, I started Sky and sold it to AAM when Geno was sold to GMR and all. Like we were capturing a very insightful and excellent delivery today, and I think a lot of people from this group will get a lot of benefits out of this particular conversation. I'm keenly looking forward to meet you with a lot of ideas and stuff like that. So together IIT NIF and IIT Kanpur can work together on some of these startup ideas. Thank you so much.
Yeah, thank you, Srinivas. Good that you have joined IIT Tirupati now.
Yeah.
We have been interacting a lot. Yes, we interact more.
Yes.
And now we share same kind of thing. We both are in IITs. We both have industry interest. So
yes,
looking forward to interact.
Thank you.
Hello.
Yeah, please go ahead.
Yes, Bharat sir, I am Divyesh from National Forensic Sciences University, Gandhinagar. So currently we are working on the LIDAR part for mapping the indoor navigation premises and facilities. So my questions regarding to the start from to the end of from data acquisition to the processing of the LIDAR data and delivery to the end client. So sir, can we simulate all the process at the one line, like solutions from the one line as a startup? Like can we start in that context from right to acquisition to deliver the indoor navigation facility?
Okay, so yeah, if I understand your question correctly, and I will again bring the perspective from the company in UK which I told you about, and
Yes,
where my friend is working. And LiDAR sensors for indoor mapping along with the other sensors also, yes, that's the right way to do. And the way that company is working, as I said, they have already 1 lakh properties done.
yes.
And so because once you do it, you need who will buy it from you. Ultimately, you need someone who can buy this data from you. So for example, that company is selling these data to the real estate companies. For example, a house needs to be re-rented. Okay, so someone who is going for that house, and instead of going to the house and visiting that, rather a 3D model of the house is being presented to the people online. So they're working with that model. They're working indoor in the warehouse mapping, because in large warehouses, for Amazon warehouse, for example, they need to map their indoor environments very regularly, because they need to know where the stuffs are, how to manage the logistics inside their warehouse. So they need that indoor mapping. They are also doing it for the hospitals. They are doing it for large buildings, as I said, the 5 stars and others. They are doing it for those purposes also. Now, the pipeline from data capture to process to delivery to the final client, they are, I think the way you will move into it, you'll have your own pipeline. But the recent pipeline, which I noticed, I found, and I think a startup should go for that, is, today a lot of this data capture is fine. Capture can be done by different kinds of sensors, different technologies. But once the data is captured, you need to vectorize this data. Okay, so then you have to select the platform and other things. And that vectorization process is very tiring, highly cumbersome process, and that is the most expensive process. So this is where, for a startup, my suggestion will be that bringing the deep learning into it. Okay. And I have noticed for some companies, again, working on indoor environment, in my interaction with them, I learned that once earlier they were doing all this process manually, okay, then extraction of the features and vectorization of the data, everything they were doing manually. Then they started using the deep learning in that. So what he told me, that they are doing now 4 times the work which they were doing earlier with the same number of people. So their productivity has increased 4 times once they have used the deep learning algorithms in the initial stages. And then editing requirements are reduced, isn't it? So I don't know whether I'm answering your question correct or not, but
yes, sir, definitely, yes, sir.
To a startup, my suggestion will be this: that start adopting deep learning. And of course, initially you will have a problem. Your people will not like it. Like in that company also, they didn't like it because they had a very set pipeline: data capture, digitize, generate the product, pass it on. Right. But once you bring the deep learning, there is an additional thing in between. And this additional thing, now your digitizer people, they will not like it because they have to find new ways of digitizing. They have to understand the output from the deep learning, and then they have to digitize. So they didn't like it because, in any system, we have the inertia. But once they kept on doing it, after that, they liked that process. They have now a new pipeline where this deep learning is really helping them and improving their productivity by 4 times.
Okay, yes, sir. And sir, one more I want to insights regarding the this indoor facility. Sir, can we get the real-time locations of the peoples inside the premises, and we can display on the 3D models of the radar?
Yeah. Ideally, you can do the real time also. Why not? Because if you are using the sensors which are placed, for example, I interacted with a company in USA, I guess Verizon, and their requirement is for a football stadium, they want to manage the movement of the people.
Yes.
Okay, so the crowd management, basically the crowd management. Now, if I'm using the camera has one problem. Camera has the problem is, of course, the depth perception by the camera is not good. Number one, it can't work in the dark area. Number two, number three, another very interesting thing with the camera, which is camera does not maintain the privacy of people, because in camera you can read the face of people. But the moment you start using the lidar, very good depth of perception, very good 3D geometry. It can work in dark areas also. And again, what you get, okay, there is an individual, but identifying that who is that is not possible. It's very difficult, I would say. Right, so LiDAR sensors are being recognized because they maintain the privacy. So what was his problem? He wanted to place in that football stadium a couple of LiDAR sensors in different places, and then see whether these sensors will be able to, manage or generate the information for managing the crowd or not. So again, why he approached us, because we have a LiDAR simulator. As I said, in 2007 or so, we started working with the LiDAR simulator, and today also we are working with the LiDAR simulator. And now our LiDAR simulator is finding interest in autonomous vehicle area also. So today it is possible for me that I can simulate that environment of football stadium. Then I can choose some LiDAR sensors from the market. I can place them in my simulation system in different places. And then in my simulation environment only, I can move the models of the human being and I can generate the data. Now this data I'm generating in simulation environment in my computer. Now whether that data is good enough, because I will pass this data to my deep learning engine. And then my deep learning engine, whether it is able to identify people, whether it is able to identify the vector of movement of the people or not, this I can make an assessment. So before I really invest into LiDAR sensor from the market, I put it in 10 number of places in the football stadium. I can run this exercise within my simulator, isn't it? So
yes.
as you said, your question was people identification, real-time identification of the movement of people. Yes, it can be done, because that's the application which I was talking with the Verijan.
Yes, thank you very much, sir. Thank you.
Any other questions from participants? Okay. Thank you, sir. Thanks for that nice talk. And also, like, there are many startups will come in the future, I think, because of the new geospatial data policy, which was implemented in the last year. And also, we have also attended some of the geospatial conferences, and we have seen plenty of companies are coming. So hope this will drive the country in a positive approach, especially in this. Thank you, sir. Thanks once again.
Thank you very much. Thank you all.
Participants will continue the sessions in the afternoon. So around, I think, afternoon session is at 2:30 by the Lieutenant General Dr. Anil Kapoor. Will talk about again some opportunities and innovation and challenges in geospatial technologies. Followed by that, our CEO will give a talk about the opportunities in geospatial. Thank you. Please join back at 2:30. Thank you all. Please share the feedback also in the form which we have provided. Okay. I will end the session. Please join back at 2:30. Thank you all.